Hey folks, this is what I believe to be one of the coolest little topics that we're going to do all year. And I'm going to break it down into a method that I think is really cool as far as being able to not have to use a calculator to do the unit circle. You also don't have to do a bunch of like mnemonic devices or finger tricks or anything else that I've seen on the internet. It's just good old basic. What did we do in geometry when we did right triangle trig? And we're just going to use that information plus very basic algebra and a little bit of geom to fill out our unit circle. All right, so here we go. This is stuff that we did in geometry. It included special right triangles. So if you remember the 45, 45, 90 special right triangle and the 30, 60, 90 special right triangle. Okay, and we learned back then that the sides in these triangles can be found by using certain ratios. All right, now the ratios in a 45, 45, 90 right triangle are 1 to 1 to the square root of 2. Right? Well, we just remember the legs have to be congruent because you have an isosceles triangle here. If the angles are congruent in a triangle, then the opposite sides are also going to be congruent. And then in order to find the hypotenuse quickly without using the Pythagorean theorem, you can simply take one of the legs and multiply it by the square root of 2 to find the hypotenuse. Okay, so hopefully you can remember that. When the 30, 60, 90 is given to us, if we have the shorter leg, then in order to find the longer leg, we multiplied by the square root of 3. Okay, so that's why I put longer leg is root 3 times the shorter leg. And then if we wanted to find the hypotenuse, we would simply multiply the short leg by 2. Okay, so that is what we did back in geometry. Okay, so let's just review that just a bit and go from there. So it says if we know the hypotenuse of a 45, 45, 90 right triangle, then what would be the measure of one of the legs? Well, we just said that if we knew the leg and we multiplied by root 2, we would get the hypotenuse. So if we know the hypotenuse and we want to find the measure of one leg, we would simply divide the hypotenuse by root 2. Okay? And just remember that you're going to need to, in most cases, rationalize your denominator. Okay? We don't want to have a square root in our final answer's denominator. So we might have to, if, like, for example, if the root 2 is in the denominator, if we had, for example, like 5 over root 2, we would have to multiply the numerator and denominator by root 2, so we would get 5 root 2 over 2 for our final answer. Right? So if you remember to rationalize your denominator, that will help as well. Okay? So what about if it's a 30, 60, 90 right triangle? If it's a 30, 60, 90 and we know the hypotenuse, how could we find the shorter leg? Well, if we have the hypotenuse, okay, and we want the shorter leg, instead of multiplying by 2, we simply divide the hypotenuse by 2. Divide the hypotenuse by 2. Cool. So then, once we have that short leg, how do we find the longer leg? Well, we would find it the same way we did before. The longer leg is root 3 times the short leg. So the longer leg would be longer leg equals short leg times root 3. Okay? That's all there is to it. And again, make sure that you remember if there's a denominator with a square root, that we're going to have to rationalize that. All right, so now I'm giving you a 45, 45, 90 and a 30, 60, 90, and I'm giving you the hypotenuse of each is 1. And I'm asking you to find the lengths of the missing sides of the triangles below. Okay, now if you want to pause me and then go and find them, awesome. Okay, but I'm going to do it right now. So let's start with the 45, 45, 90. So to go from hypotenuse to leg, we said that we divide by √2. Okay, so we are going to take 1 and we're going to divide it by the square root of 2. Well, guess what? That has a radical in the denominator. So what I would like to do is multiply the numerator and denominator by √2 so that I get the square root of 2 in the numerator, okay, because you can have a square in the numerator, that's fine, and then just a 2 in the denominator. So since we know that one of these legs is √2/2, and this is an isosceles right triangle, okay, both legs are going to be √2/2. Right, great. So I just found both missing sides of my 45, 45, 90 right triangle. And now I want to do the same thing here with the 30, 60, 90. They've given me the hypotenuse. Okay, word of the wise, if they give you the hypotenuse, always find the shorter leg. It's always easier because you're just going to divide by 2. Right? So from hypotenuse to shorter leg, we're just going to divide by 2. So the shorter leg is going to be the hypotenuse divided by 2, which is now it's 1/2. Well, that's kind of nice. So let's put the 1/2 here. Right? And then how do you go from short leg to longer leg? Well, remember we said we take the shorter leg and we multiply it by √3. So the shorter leg is 1/2, and you multiply it by √3. Okay, so that'll give you √3/2. Right, so I have √3/2. So those are my missing sides. Okay. If you can do that, we can do the unit circle. Okay, check this out. So here we go. Now I've given you a unit circle that is blank except for 0 degrees. We get the 0 degrees here, which is also 0 radians. We've got 90 degrees up here, which is also pi/2 radians. We've got 180 degrees over here, which is pi radians. And we've got 270 degrees down here, which is 3pi/2 radians. Okay, so what I am asking you to do is to draw 30-degree reference angles in all 4 quadrants, okay? And each of them having a terminal side that intersects this circle. So let's do it in the first quadrant. Here in the first quadrant, I'm going to draw a 30-degree reference angle. So remember that with a reference angle, one of the sides of your angle is always going to be half of the x-axis. Okay, in this case, it's the positive x-axis. The terminal side is the terminal side from your angle, right? So here is your 30-degree angle, okay? We're going to do this 4 times total. We're going to do this over here in the second quadrant, 30-degree reference angle. Make my little right triangle there. Let's do this in the third quadrant and in the fourth quadrant. Let's do this here, 30 degrees. And then we'll do one more here. So we got 30 degrees right there. Okay, cha-ching. All right, now let's just work right now with the first quadrant triangle. Just looking at the blue triangle, nothing else. I know that the hypotenuse, this right here, is 1 unit long. How do I know that? Because the unit circle is a circle where the center is your origin. The center is the origin, and the radius is 1 unit long. So that's why we go up 1 unit to 0, 1. We go right 1 unit to 1, 0. We go down 1 unit to 0, -1, and we go left 1 unit to -1, 0, right? Every one of these radii measure 1 unit. All right, now this is a 30, 60, 90 right triangle. Okay, so there's a 60 up here, right? So we know from what we just did right here what those other two sides are. If the hypotenuse is 1, we know that the side opposite the 30-degree angle is 1/2, and the side opposite the 60-degree angle is going to be √3/2. So let's go ahead and just jot those in here. So opposite the 30 is going to be 1/2, and opposite the 60, right down here, is going to be √3/2. All right, isn't that nice? So now it says, determine the XY coordinates of all the 4 points of intersection with the unit circle. So the first point that we're looking at is this guy right here, right? So the XY coordinates for this point are, well, how do you get to a point on the XY coordinate? You go left to right, and then you go up or down. So if I go right √3/2, and then I go up 1/2, that means that my coordinate pair is going to be √3/2 comma 1/2. Okay, just that easy. Right? Let's go over to the second quadrant, the kind of orangish quadrant here. And let's again remember that our unit circle has a radius of 1 unit. Okay, so now opposite the 30-degree angle, it's 1/2. Opposite the 60-degree angle is √3/2. Now, just one thing here. If you're plotting points, just remember in the second quadrant, you have to go to the left, which means that your X coordinate must be negative. So this is going to be -√3/2, comma, +1/2, because you went up. Okay. All right. Now for the gray, what I'm looking at here, I'm going to be looking at going, there's a 60. Opposite the 30-degree angle, once again, is going to be 1/2. Opposite the 60-degree angle is still √3/2, right? So it's still there. We haven't messed with it, right? And right on top of it here. Okay, so we have the 3 sides, but remember, if you go to the left, you got a negative, which tells me that the X coordinate is going to be -√3/2 again. But now the Y coordinate, this 1/2 is going down. So that 1/2 is going to be a -1/2. So if I go left √3/2 units and down 1/2 unit, the coordinates are √3/2, comma, -1/2. Right? All right, now let's look at this fourth and final brownish triangle here. Again, a 30, 60, 90. We get a 60-degree angle over here, which is cool. We are going to label our sides. Well, this side is already labeled. √3/2 is opposite the 60-degree angle. And opposite the 30-degree angle, we know is going to be 1/2 unit long. Okay, it's going to be half of the hypotenuse. Hypotenuse is 1 unit. Okay, and let's see. Yeah, I probably should go back and remind ourselves that that one is 1 unit as well. All right, so what are the XY coordinates for this particular point of intersection right here? Well, the X is going to the right, so it's still positive √3/2. And then going down, it's 1/2. but down is negative. Okay, so down is negative. We know that in the fourth quadrant, the x coordinates are all positive and the y coordinates are all negative. So just remember that. Okay, so we have just drawn in 4 of our unit circle angles. Okay, let's draw 4 different ones now. We'll do a clean circle. We're going to start with 60-degree reference angles this time around. All right, so let's go with 60-degree angle right here. Drop your altitude to the x-axis. That means up here is a 30. Right? Let's do this with all the quadrants. Let's go with a 60 here. 60-degree reference angle each time. It means there's a 30 up in here. Okay. And then let's go 60-degree angle here. 30 degrees. Okay. And we'll finish up with, let's go bright. Okay. 60-degree angle here, 30 here, 90. Okay, so let's look at these. In the first quadrant, we've got this point right here that we would like to take a little closer look at, right? And we know that opposite the 60-degree angle, we already know this, we just did it in the previous triangle, it's going to be square root of 3 over 2 for the side opposite the 60-degree angle, the longer leg. The side that is opposite the 30-degree angle, the shorter leg, is going to be 1/2. So this guy down here is 1/2 a unit long. Okay. We know that the hypotenuse is 1. That's where we came up with these. We divided by 2 to get the shorter leg, and we multiplied that shorter leg by √3 to get the hypotenuse. Okay, so what are the xy coordinate pair for this particular point? Well, opposite 60 degrees. We have the x coordinate 1/2, the y coordinate √3 over 2. Right? So when we make a 60-degree angle in the unit circle, the x coordinate for that spot on the unit circle, that point, is 1/2, comma, √3 over 2. Right? Let's go over to the second quadrant. In the second quadrant, again, we have the hypotenuse is 1. That's what a unit circle is. Opposite the 60-degree angle is going to be √3 over 2. Opposite the 30-degree angle is going to be 1/2. Okay. So at this point, we now know that we are going left 1/2, so it has to be negative 1/2, and up √3 over 2. So there's √3 over 2. And there are your points. Okay. So notice that this is a 60-degree reference angle in the second quadrant, which would actually be a 120-degree angle. Right? So now let's go down to the third quadrant, and let's check out this particular triangle with this hypotenuse of 1. Okay, opposite the 60-degree angle, we know is √3 over 2. Opposite the 30, it's going to be half of the 1, so 1/2, which we've already got right here. All right, so what are the coordinates for this point of intersection with the unit circle? Well, you're going to go left 1/2, so minus 1/2, negative 1/2, and down √3 over 2, so negative √3 over 2. Okay, so that would be in the third quadrant with the 60-degree reference angle, which means that would be 240 degrees. Kind of neat, right? So let's go over here to the red angle, ruby red here. Okay, so we have, once again, hypotenuse of 1. Opposite the 60-degree angle is √3/2. Opposite the 30-degree angle is 1/2, and we already have the 1/2 there. So our coordinates are going to be, for this point right here, we know it's going to be to the right 1/2, and we're going down √3/2, so negative √3/2. So between the 30-degree reference angles and the 60-degree reference angles, we just got 8 coordinate pairs, okay, out of the 12 in the quadrants that we're going to have, okay, in our unit circle. Right? You do need the quadrantal angles. Okay? You do need the 0, 90, 180, 270-degree angles, but those are pretty simple. You know, you're either going one to the right, one up, one left, or one down. Okay? So let's finish it off here with the 45, 45. All right, and do the same thing. Let's draw them right up here, shall we? So there are my 4 45, 45, 90 right triangles. Okay. Now, all of the acute angles here are 45 degrees. Okay, so I'm not even going to label the other 4. But we have a hypotenuse of 1. So let's look at the first quadrant. Okay, first quadrant, our little red right triangle, we have a 1, and we know that if the hypotenuse is 1, remember what we did in order to find the leg. We divided by √2. Well, remember that when we divided 1 by √2, what did we have to do? We multiplied by √2 over √2. So it was √2/2. Okay. So if you remember that 1 divided by √2, which is the length of every one of these legs, is going to be √2/2. So this is going to make this one pretty quick for us here. So check this out. Okay, so this side here is √2/2. This side here is √2/2. Okay. Well, that should make it pretty simple for our XY coordinates. So √2/2, √2/2. Okay. Let's go over to second quadrant. Right, same thing. If the hypotenuse is 1, then we divide 1 by √2, and we get √2/2 for both of the lengths of the legs of this triangle. Okay, so what are the coordinates of this point of intersection? Well, remember, it's in the second quadrant, so the x has to be negative because we're going to the left, so negative √2/2, and then the y coordinate's positive because we're going up, so positive √2/2. Right? In the third quadrant, very, very, very similar. We have the 45, 45, 90. We know that opposite the hypotenuse is a 90-degree angle. The legs are opposite the 45-degree angles. Okay? How do we go from hypotenuse to leg? We divide by √2. So once again, we get √2/2 for all these sides. Okay? So this one here is already there. Okay? And this point right here is negative √2/2, comma, negative √2/2. All right, very nice. Let's go over to our orange triangle. Okay. Similar story once again. It's isosceles, so √2/2 is the measure of each leg of the 45, 45, 90 with hypotenuse of 1. So that tells me that my point of intersection right here is going to be positive √2/2 for my x, and then it went down, so negative √2/2 for my y. Okay, so from that, man, we could fill in this unit circle. Okay? We could fill in this unit circle. I mean, let's start with the easiest of the easy. Okay, the easiest of the easy, I would say, would absolutely have to be our quadrantal angles, which are 0 and 90 and 180 and 270. All right, so let's slide right down here to 0. Okay, so at 0 degrees, which is also 0 radians. By the way, it's also 360 degrees, which is 2 pi radians. The coordinates pretty simple. You went 1 unit to the right, so it's 1, 0. Okay. Easy peasy. So now we go up to 90 degrees, which is pi over 2. And we know that since we went up 1 unit, this is going to be 0, 1. Okay. Now if we go over here to 180 degrees, which is pi radians. Okay, if we go into the left, then that is going to be -1, 0. Now we go down, down, down to 270 degrees, which is 3 pi over 2 radians. And that is 0, -1. Okay. So again, we just got the gimmies right there. So now let's look at, let's do our 45s. Our 45 should be the easiest, okay? 45 degrees. We can save the whole radian bit for later if you would like, okay? But 45 degrees, all right, which, yeah, let's not save it. 45 times pi over 180 gives me pi over 4 radians. Right? Now, we know that the x and y coordinates for pi over 4, okay, if you just remember the right triangle, are going to be √2 over 2, √2 over 2. Right? Isn't that great? And then if you come over here to the 45-degree reference angle in quadrant 2, which would be 180 minus 45. So 180 minus 45 is 135 degrees. Okay. And 135 degrees is equivalent to 3 pi over 4 radians. Again, take 135, multiply it by pi over 180 and reduce your fraction. And we have the √2 over 2's again for the 45s. So in the second quadrant, all of my x's are negatives. So negative √2 over 2, then positive √2 over 2. If we slide down to the third quadrant, okay, in the third quadrant, the 45-degree reference angle will be 180 plus 45, which is 225 degrees. And that will give you a radian equivalent of 5 pi over 4 radians. Okay, again, we're talking 45-degree reference angle, so it's √2 over 2, √2 over 2. Right? We're in the third quadrant, so both x and y are going to be negative. So negative √2 over 2 for the x and negative √2 over 2 for your y. Let's move it over to the fourth and final quadrant. Okay, so 45-degree reference angle, so it'd be 360, take away 45. We're going to keep it positive. We're not going to say negative 45. 360 minus 45 is going to be 315 degrees. Okay, so that would be, again, multiply by pi over 180 degrees, so 315 over 180, and you reduce that down, you're going to have 7 pi over 4 radians. And we once again have our √2 over 2's because it's a 45-degree reference angle. In the fourth quadrant, you go right and down. So the x-coordinate is going to be positive. The y-coordinate is going to be negative. Okay, that cool? Good stuff. So we have a little over a third of our angles. So now let's look at, well, let's start with our 30 here. 30 degrees, 30 times pi over 180 will give you pi over 6, because 30 over 180 is 1/6. Okay, now let's think back. Think back to our triangles. And if you don't think back, just remember that you can always do the following. You can always say, I've got a 30-degree angle right here. My hypotenuse is 1. Okay, how do I go from hypotenuse to the shorter leg? Well, I divide it by 2. Okay, so that'll be my y-coordinate. I know that my y-coordinate is going to be a half. Okay, and then how do I go from the shorter leg to the longer leg that's opposite the 60-degree angle? Well, I multiply it by the square root of 3. So this is going to be root 3 over 2. So that's going to tell me that my x-coordinate is going to be root 3 over 2. Okay? Now, you can just write that off to the side somewhere if you want. You don't want to get your pretty little unit circle too messed up. But if you just remember your special right triangle and your ratios for 30, 60, 90, that should be a pretty simple one. So anything with a 30-degree reference angle, it's going to be root 3 over 2 and a half. Okay? Let's go just revisit that for a second. Okay? 30-degree reference angle. Okay? It was always root 3 over 2 for my x, whether it's positive or negative, and it was always the 1/2 for my y, whether it was positive or negative. Okay, so all of my 30-degree reference angles give me root 3 over 2, comma, 1/2, all of them. So if I can just remember that, well, I can be filling in some unit circle stuff right now. So let's do that, shall we? Okay, so I just paused it and just put in the XY coordinates for all of the 4 angles that we have here that have 30-degree reference angles in this unit circle. Okay, I didn't label the degree measure or the radian measure yet, but I will. So looking again, it's all root 3 over 2, comma 1/2. Root 3 over 2, comma 1/2. It's just that in the second quadrant, your x is negative. In the third quadrant, they're both negative. And in the fourth quadrant, your y coordinate is negative. Right? So now let's just look at the angles themselves. Right? So in the second quadrant, what we have here is 180 minus 30. Okay? And 180 minus 30 is 150 degrees. And 150 degrees times pi over 180 degrees gives me 5 pi over 6, or 5/6 pi. Okay, moving down to the third quadrant. Okay, so this is 180 plus 30 degrees, so that's a 210-degree angle. 210, okay, times pi divided by 180 is going to be 7 pi over 6, or 7/6 pi. And then last but not least, over here in the fourth quadrant, it's going to be 360, take away 30. So that's going to be 330 for the degrees. 330 times pi over 180. Okay, this is going to be 11 pi over 6. Okay, so we've now done the 45s, we've done the 30s. Let's just finish off with our 60s. Okay? And with our 60s, we have, we'll start right here with our 60-degree angle. Okay? Remember, 60 times pi over 180 is going to be pi over 3 radians. Okay, for 60-degree angles, right? Remember when we did the triangle, the x coordinate was 1/2 and the y coordinate was √3/2. Right? And one helpful thing to remember, whatever the 30-degree XY coordinates are in that quadrant, the 60 will be the exact opposite. You will flip the X and the Y coordinates. So in the first quadrant, the 30-degree angle intersected the unit circle at √3/2, 1/2. So now at the 60-degree angle, we're going to switch them. It's going to be 1/2, √3/2. Okay. So let's move over here. 60-degree reference angle. So 180, take away 60. We're going to have 120 degrees. We're going to have a radian measure. Okay, 120 times pi over 180 gives you 2 pi over 3, or 2/3 pi. And once again, because it's a 60-degree reference angle, it's always going to be the 1/2 and the √3/2. But because we're in the second quadrant, your x is going to be negative. Okay. Hopefully you see the symmetry here. You see, the 120 and the 60, and the 135 and the 45, and then the 150 and the 30. They all have the same reference angles. They're all going to have the same XY coordinate, just the signs will be different. Okay, let's go down to the third quadrant. Okay. In the third quadrant, 60-degree angle, 180 plus 60 is going to be 240 degrees. Okay. And 240 times pi over 180 is going to be 4 pi over 3 radians. Okay. And then once again, we are going to have the 1/2 and the √3/2, but we're in the third quadrant, so we are going to have negatives. Okay. And then notice once again that your XY for your 30-degree reference angle is the exact inverse of your XY for your 60-degree reference angle. Okay, we only have one angle left here. In the fourth quadrant, okay, 360, you're taking away 60 for the reference angles. This is a 300-degree angle. Okay, 300 degrees times pi divided by 180 gives you 5 pi over 3, or 5/3 pi radians. And let's go ahead and take a look. There's the 30-degree reference angle, √3/2, -1/2. Okay. Again, reminding you, you're going to be swapping them. So it's going to be the 1/2 comes first, and the √3/2 comes second. But because we are going down, the y coordinate is negative. Okay, so we have filled in this whole unit circle. We haven't taken a calculator. We haven't done anything except for just remember what your special right triangles gave you in your 45s and your 30s, 60s, 90s. Okay, if you remember that first page, then you can get all of it. Okay, the only information we didn't formally cover in this particular video was what we have done previously, and that is if we have an angle measure in degrees and we want to make it into radians, we will simply multiply by pi radians over 180 degrees. The degrees will cancel. Okay, you can put 1 under there, so you would get your pi over 6, right? But that's prior material, just reminding you of it. But that is filling out the unit circle without the use of a calculator, just with some geometry. Hope you enjoyed it. It's cool stuff. See ya.